Okay, so for this one here, to find the term independent of the expansion of this here, what we notice is that, of course, you have one binomial, so let's call this number 1 here, and this is number 2. And of course, the expansion of this one here is going to be expanded into this one here, and somehow numbers from this one will cancel, or pardon me, x terms from this one will cancel x terms from this one. And the only way that is possible is, let's imagine we take the a to the x cubed. So imagine this produces some constant a times x cubed. And that one here multiplies, and let's say we expand this, and this produces something like, I don't know, some b constant over x cubed. Okay? So if this happens, this term from this expansion multiplied from this random term in this expansion, well, these cancel and you will have a times b, which is a constant term. Okay? So we have to see how this will multiply into this, and there could be various numbers. All right, so let's see. I mean, for instance, this binomial is going to have something with x to the power of 7 plus something to x to the power of 6 plus all the way down here to the 1. And of course this one here, if we did the 3 bracket rule, you could have x here and minus 2 over x, and one term could be 5 comma 0. If we do this again, it could be 4 comma 1, and then another one, it could be 3 comma 2. And so all these ones will produce different variations of x depending on x canceling out. Okay, so in this case here, minus 2 over x to the power of 0 is, well, 1. So you'd have x to the 5. And if you have x to the 5 times by any expansion here, there's no way you're going to have constant, because this automatically has x to the 5. So we can rule out x to the 5 in this case. Okay, so how about x to the 4th? Well, we have this minus 2 over x. Okay, so in this case, we're going to have x to the 4. Here, let me do this over here. So if this is the case with this one here, you have x to the 4 times minus 2 over x. And one of your x's is going to cancel, so you'll end up with something with x to the 3. And of course, if that from number 2 multiplies anything in here, you will still have an x term. So x to the 3 doesn't work. And if you actually look, any time that this number is higher than this one, they will not cancel out enough x's. So x to the 3, it'll be x cubed times 1 over x squared, so then that won't work. And we can keep trying out what will happen. So x2 and 1 over x3. And if you look here, you'll have x squared times, let's say, I'm not too worried about the negative 2 right now, I'm worried about the x's. X cubed. So if this is the case, you'll have an x squared gone away, and x squared will go away, so you have a 1 over x. So in this one here, I'm going to highlight this in a different color. Here is an exception where one of the x's here can multiply by one of the terms here and cancel out an x. So x times 1 over x, and this will give you some constant. So in this term here, from number 1, we for sure need the x to the 1 term, because that will cancel out this term here. Okay? So there's our first. Now we continue on. So if we have, let's see, change back. If we have x, and now we decrease this by 1 again, and then increase this by 1 over x, and 1 more, so 4 plus 1 is 5. Now we're going to get, if we multiply these two together, you should get x over x to the 4, which gives us 1 over x to the 3. Okay, so 1x cancels, and we should have 1 over x cubed. So we need, the second term we need from this guy, right, is the x to the power of 3, because that x cubed will multiply this x cubed term and cancel it out. Okay? And if you notice, it goes 1, 3, and I bet you we'll have 5 next. Okay? So the third term, I'm sure, will be x to the power of 5 that we're going to have to find in the number 1, this binomial here. So if we look at that, just to make sure we're safe, we have x to the power of 0 times 1 over x to the power of 5 to the power, or pardon me, this to the power of 5, and of course this is 1, so yeah, we're going to have 1 over x to the 5, and that's from number 2. So we do need these 3 terms from binomial 1, and these 3 terms here, so let's underline this. We need this one here, different color. So we need this one here where it's x0 and the other 1 to the 5. We need x1, other 1 to the power of 4, and x2, 1 over x to the power of 3. So we need these 3 terms times by these 3 terms to cancel out all the x's. Okay? So let me just make my canvas size a little bit bigger. Okay? So if we go back here, and alright, so we have 2x plus 1 all to the power of 7. So let's get these 3 terms first. So that means we need three brackets from 3 terms. And our n for this one is 7, so this goes here, this goes here, this goes here. This number here is 2x, 2x, 2x. This is 1, 1, 1, and we need x to the power of 1. So this will be our x to the power of 1, x to the power of 3, x to the power of 5. So in order for that to happen, this has to be 1, this has to be 3, this has to be 5. If this is 1, it has to add up to 7, so this is 6, and this is 6. If this is 3, it has to add up to 7, so we have 4, 4, and this finally we have 2x to the 5th, this has to be 2 and 2. So let's mark these other ones with a different color here so we know which ones we're multiplying against. So this is number 1, this is number 2, and this is number 3. So we multiply number 1 with 1, 2 with 2, and 3 with 3. So you can work this out on your calculator. And now we need the 3 from the other ones. So I'll use a different color here. Let's try blue. This is a nice color. Yeah. Okay, so let's create 3 of these ones here. So the other binomial was x minus 2 over x to the power of 5. So let's look. Let's do our 3 bracket rule. 1, 2, 3. And we need 3 of them. 1, 2, 3. And finally, we need another 3. 1, 2, 3. And this is going to be our 1 over x term. This will be 1 over x cubed term. And this will be 1 over x to the 5 term. So this is 5, 5, 5. We have x, x, x. Minus 2 over x, minus 2 over x, minus 2 over x. And now we have, okay, so we need 1 over x. So we figured out earlier on that in order for that to happen, we have 2 and 3 here. 2, 3, that means this is 3. And then this was reduced by 1 more, so 1 and 4. And 4, if you saw above, and this is 0 and 5 and 5. So now all we need to do is take our calculator and figure out what these numbers are, the numbers in front of these, and that will multiply. So these 2 here, oops, use one more other color from here. So, oops, let me try this again. This one here, these 2 will multiply. these two will multiply, and finally these two will multiply. And depending on if it's a paper 1, paper 2, paper 3, you can use your button N, choose R to find out these 5, 5, 5, 5, 4, 5, 3, or you can use Pascal's triangle. And yeah, it looks like I think a bunch of 2's will cancel as well. So this is 2 cubed. This is 2 to the 4th, so with a little bit of extra math help you can realize how things will quickly cancel each other. So let's see how that works. Okay.